Okay, so in this video, we want to review the definition of a logarithmic function. So if you recall, a logarithmic function is, by definition, the inverse function of the corresponding exponential function. So we take here a as the base of our exponential function, and a is any positive real number. Then we consider the exponential function base a, y equals a to the x. Then by definition, the inverse function of the exponential function base a will be the logarithmic function base a. And we write this as log subscript a for specifying that the base is a. So this means the inverse function of the exponential function base a. And of course, we have a function of x. So it's log base a of x. So if you recall in general, the relationship that exists between a function and its inverse is the following. So if you have, in general, any function of x, so y equals f of x, and its inverse function y equals f inverse of x, the inverse by definition cancels the original function via composition, which means if you compose f of f inverse of x, the function will cancel with the inverse, and you will simply obtain the original argument back. And the order of the composition is irrelevant. We can compose the two functions in opposite order, so we can do f inverse of f of x, and once again we are composing a function with its inverse, so the two will cancel, and we will once again obtain the original argument. This is a defining property of the inverse relationship between two functions. They cancel each other out via composition. So if we go back now in the special case of the logarithmic function base a and the exponential function base a, this means that if we compose these two functions in either order, the result will cancel and return the original argument. So what if we take the exponential of the logarithmic function? Well, we take x, apply the logarithmic function base a to x, then apply the exponential function to this. But again, by definition, the logarithmic function base a is the inverse of the exponential function base a. So these will cancel, and we return with the original argument. And of course, this goes both ways. If we take the logarithmic function base a of the exponential function base a, once again we are composing a function with its inverse, so they cancel, and we are left with the original argument. So again, to summarize, a logarithmic function base a is nothing more complicated than the inverse function of the exponential function base a. And that's it.